Launching an aircraft in just a second and stopping precisely isn't a cinematic stunt. It's a signature capability of the Fujian aircraft carrier. Beneath the deck, embedded in the electromagnetic catapult track, lies a powerhouse known as the mover, the core component that drives the entire catapult system. It locks onto the aircraft's landing gear, accelerates instantly using electromagnetic force, and propels the fighter jet into the sky. Once the aircraft leaves the deck, the system recovers energy through electromagnetic braking and resets itself for the next launch. Although today's carrier aircraft can take off in only 2 seconds, achieving this milestone took more than 2 decades of relentless effort. We successfully launched multiple carrier-based aircraft in succession with 0 failures, an achievement unprecedented in the history of carrier catapult technology. Looking down at the Fujian's vast flight deck, you'll notice a raised dome structure. This is the command, control, and interaction hub of the electromagnetic catapult. Officially called the Integrated Catapult Control Station, the crew simply refers to it as the bubble. It serves as a crucial link connecting the flight deck, carrier-based aircraft, and the catapult system within the overall command chain. This station handles all pre-launch preparations, configuring the catapult, running system checks, inputting parameters, and executing the final launch command. The principle behind the electromagnetic catapult is similar to that of a maglev train. Modern power electronics convert the ship's electrical energy into stored mechanical energy. When launching an aircraft, that stored energy is released as high-frequency pulses, generating magnetic fields and currents that accelerate the aircraft with electromagnetic force. The Fujian's electromagnetic catapult provides a powerful technological foundation for achieving air superiority in distant seas. When this core technology was applied to amphibious operations, it led to the creation of the world's first amphibious assault ship equipped with an electromagnetic catapult, the Sichuan. The Navy's Sichuan, hull number 51, represents a new generation of amphibious assault ships. Its dual island design allows each island to specialize. The forward island handles navigation and coordination within the fleet, while the aft island manages air operations, directing drones, helicopters, and fighters to greatly enhance combat efficiency. How advanced is the Sichuan? With a displacement of over 40,000 tons, it ranks among the largest amphibious assault ships in the world. Greater tonnage means longer range and the ability to carry more advanced weapons and equipment. Traditional amphibious assault ships have limited deck length and surface area, so the aircraft they carry typically must be capable of short or vertical takeoff and landing. The Sichuan features a full-length, through-deck design equipped with electromagnetic catapults and a resting gear. This allows it to operate a wide range of fixed-wing aircraft, helicopters, and large drones, and to launch them via electromagnetic catapult with higher efficiency and faster takeoff speeds. While the Sichuan's electromagnetic catapult technology traces its origins to the Fujian aircraft carrier, it incorporates several adjustments in power output and specialized design features. The biggest difference is that the Fujian must launch heavy, fixed-wing aircraft, such as airborne early warning planes and fully loaded strike fighters. As an amphibious assault ship, the Sichuan's catapult system is tuned to efficiently launch larger numbers of drones, greatly enhancing its capabilities in reconnaissance, surveillance, and transport missions. The Sichuan not only elevates China's amphibious operational capabilities, but also opens the door to exploring whether other ship classes should adopt smaller electromagnetic catapults to boost future efficiency. The true value of electromagnetic catapult technology goes far beyond launch efficiency. Its real impact lies in reshaping the entire takeoff and landing architecture of carrier aviation, enabling coordinated upgrades across key carrier systems and expanding the future combat potential of carrier strike groups. On September 22, 2025, the Navy announced that the J-15T, J-35, and KJ-600 carrier-based aircraft successfully completed their first catapult-assisted takeoff and arrested landing training aboard the Fujian. This marked China's first successful electromagnetic catapult and recovery of multiple advanced carrier-based aircraft types on a catapult-equipped carrier, confirming the Fujian's full launch and recovery capability. Globally, a mature aircraft carrier must possess strong, well-rounded combat capabilities, including air superiority, sea control, early warning, electronic warfare, and anti-submarine operations. Military enthusiasts refer to the core aircraft that enable these capabilities as the Carrier Aviation 5-piece set. This 5-aircraft system forms the backbone of modern carrier combat power: stealth carrier-based fighters, multipurpose catapult launch fighters, fixed-wing early warning aircraft, fixed-wing electronic warfare aircraft, and anti-submarine helicopters. This is the Shenyang Aircraft Corporation hangar, and behind me are two J-15T fighters. The T in J-15T comes from the first letter of the Chinese word tan, meaning catapult. This long, slender rod is the catapult bar, a component designed specifically for the J-15T to enable catapult-assisted takeoff. It hooks directly onto the electromagnetic catapult on the carrier deck, accelerating the tens of tons J-15T from a standstill to hundreds of kilometers per hour in an instant, pulling the aircraft off the deck. As you can see, the structure isn't particularly large, roughly the thickness of an arm. To achieve the required strength, it's made from high-strength steel. Structurally, the grooves carved into it help reduce weight while maintaining strength, contributing to the overall weight reduction of the aircraft. On an aircraft carrier, this catapult bar connects directly to the catapult system. Behind it is a joint that attaches to the carrier's tow bar, temporarily securing the aircraft before launch. The entire catapult launch process is similar to firing a slingshot. The retraction bar acts like the point you pinch, the catapult bar is the rubber band, and the catapult system is the handle. When the force reaches its peak, the tow bar automatically releases, and the catapult accelerates the aircraft forward together with the catapult bar. Carriers equipped with catapult launch systems typically have multiple catapults installed on the deck. A catapult system generally consists of a power unit, a shuttle reciprocating vehicle, and a guide track. The shuttle on the guide track grips the aircraft's nose landing gear, powered by the system, pulls the aircraft forward at high speed, ultimately launching it like a slingshot. Whether during catapult launch or arrested landing, the J-15T endures massive impact forces comparable to a tens of tons object hitting the ground from several hundred meters up. To withstand this stress, the J-15T's nose landing gear is visibly thicker and stronger than that of the ski jump J-15. The difference is obvious at a glance. This isn't just a simple reinforcement, it's essentially a complete redesign of the nose gear. Another subtle change is that the J-15T's nose sits lower than that of the standard J-15. The purpose is to ensure the catapult bar aligns with the catapult system in a consistent, fixed position every time. This improves docking efficiency and speeds up aircraft dispatch, which is crucial for enhancing overall combat effectiveness. Take another look at this hook. Its shape is more like a shallow groove. This design serves two main purposes. First, it grips the arresting cable securely. Second, it allows the aircraft to automatically disengage once it comes to a stop. If the hook were shaped like a traditional fishhook, it would require manual removal every time the aircraft landed, which would slow down operations. On an aircraft carrier, rapid recovery and quick turnaround are essential. Automatic decoupling lets the aircraft clear the landing area immediately, improving efficiency and significantly boosting the carrier's overall combat capability. With several new carrier-based aircraft now unveiled, the Navy has assembled its Carrier Aviation 5-piece set, forming the foundation of a modern carrier air wing. The electromagnetic catapult system enables aircraft to launch with full fuel and full weapons load. Full fuel extends range, increases combat radius, and allows longer on-station time. Full weapons load means greater strike capability. The J-35 can penetrate enemy air defenses with its stealth design, while the J-15T, able to launch fully fueled and fully armed, can deliver heavy payloads over long distances for saturation strikes.